let's try to do a little bit more of that square root stuff. Or it's not just square roots, radicals, but let's backtrack a little bit and do. I think we might have done the same exact one yesterday. Let's do it again, just for fun. I tell you what, let me do this. Let's switch it up a little bit. Let's make it 12 over the square root of 3. All right. Yeah, we are. We're going to do this one first, okay? Then we're going to work up to that one we did yesterday. This is just kind of like a little reminder, right? So to get it a little bit more fresh in your brain right there. All right, so let's take a look at this. So the problem will say to simplify. I don't know. It looks pretty simple to me. I can't take the square root of 3, right? And that 3 won't cancel with that 12. There's really nothing I can do, is there? Or is there? Why is this not simplified? Why do they say to simplify? It looks simplified to me.
Square root in the bottom.
That's right. You can't have a root in the denominator. Okay, you can't have a square root or any root in the bottom. Why? I have no idea. All right, it just somebody made up the rules and said it's not simplified if you have a square root in the denominator. So
yeah,
that's what we'll do.
If you have one in the numerator.
It is. It's perfectly fine. So who knows? Go figure, right? Why you can't have one in the denominator, but you can have one in the numerator. But that's the rule, and that's what we're trying to do here. So let's try to get rid of this square root down here. Now remember, if I take a square root and multiply it by itself, that'll get rid of the square root, won't it? For instance, I'm kind of leading up a little bit to the next problem right here. So this is 3 to the what? First, isn't it? Square root of 3. Okay, I'm doing that for a reason. Watch this. So what do? I multiply by 3 to the... Now, what number is going to make... Because I want this 3 squared. I want that square root to cancel out that squared right here. But what am I going to have to make this in order to make this thing a squared? Make that a 1. Do you see what I'm doing? You may not see why I'm doing this until the next problem, okay? But I'm trying to show you something. Hopefully it'll make sense a little bit. So what I'm doing is I started off with a square root of 3. I need to multiply it by something that's going to make this thing come out to a nice square root of 3 squared. Does that make sense? Because what is the square root of 3 squared? What happens to that square root and that squared right there? What is it? They cancel each other out. That's right. So whatever root this is a square root or a second root, all right? It's going to cancel out with this squared or the second power. The second root will cancel out the second power. For instance, what if I did this? Again, I'm leading you up to something here, okay? I'm doing this for a reason. What if I had this? Let's just use x. What if I had the third root of x? What would I have to multiply that by in order to get rid of that root and just get an x? Okay, so I have to multiply by the cube root of something. Well, x cubed... Because this is x to the first, isn't it? That's right, you got it. Okay, I'd have to multiply it by an x squared, because what am I trying to get? I'm trying to get this. I'm trying to get the cube root of x cubed. So what in the world do I multiply this by in order to get x cubed? I multiply it by an x squared. Yeah, because the cube root of x cubed is just x, isn't it? Put it right there. Let's do another one. What about the fourth root of x? What do I have to multiply that by in order to get rid of that fourth root? Remember what I'm trying to make it look like. I'm trying to make it look like this. I want to make it, how would I get rid of that root? Make it x to the what? Fourth. Because the fourth root of x to the fourth will cancel each other out. Everybody see that? So whatever your root is, you have to have that same exponent inside of the root in order for it to cancel out. Does that make sense with the squared? Because this is a square root. The square and the square root cancel each other out. The cube root and the cubed cancel each other out. The fourth root and the fourth power will cancel each other out. But the question is, the big question is, what do I have to multiply this by in order to get x to the fourth? X to the third, or x cubed. Make sense? That's going to help you with the next problem. I probably went a little too far instead of doing this, but that's the whole idea. So what are we going to do here? Let's go back to this problem. What about this? What do I have to multiply this by in order to get the square root of 3 squared? Just the square root of 3. And then I do the same thing to the top. Okay, remember that? Why do I do the same thing to the top? Is it because there's a rule that says whatever you do to the bottom, you do to the top? Is that a rule? No, it's not a rule. What did we really do here, though? We made this into a 1. Good. That's why I always make it a different color, so it stands out a little bit. All right. So that's really a 1, isn't it? All right. So let's now multiply them together and see what happens. Now remember why I multiplied these two together. So the square root will go away. All right. And that's exactly what happens here. So the square root of 3 times the square root of 3 is just plain old 3. And then what about the top?
12
It's 12 square root of 3. Do we circle that? Do we circle? Are we done? Ashley, what do you see?
You can cancel out the 3 and make the 12.
Exactly right. Everybody see that? So you've got to cancel stuff out. On that quiz, I was so surprised at so many times where people didn't cancel stuff out. I think I gave it most of the time. I think I gave it to you if you didn't cancel stuff out, and I put on there reduce or something like that. I'm not going to ask you who did it, but maybe you saw that on your quiz. Always reduce your fractions. Even if your fractions are exponents, always reduce your fractions. Okay, so 3 goes into 12 4 times, and there's your answer. It's 4 square root of 3. So that is this simplified. It's the same exact thing. Put this in your calculator, you'll get some decimal number. Put this in your calculator, you'll get the same exact number. It won't even be off any decimals. It'll be exactly the same. All right, this and this. All right, try it if you don't believe me. All right, now we're ready to do this problem that we were working on yesterday. What was that? Was it the 4th root of 3 over 5? Is that the one? Okay, so let's do the same exact problem. So the 4th root of 3 over 5. Now, all that stuff we did up here, all this mess right here, we're going to use that in this problem. Okay? So let's start it. Now, hopefully you understood the first part. If you have a fraction inside of a root, we can just break it down into just put the root on the top and on the bottom. Remember that from yesterday, right? Okay, so that wasn't hard. That was the easiest part of this. So we just put the 4th root of 3 over the 4th root of 5. Don't forget that little 4th root thing, okay? Now, this is not just a square root, is it? It's a 4th root. So we have to get rid of the 4th root. Now, this is 5 to the 1st, isn't it? So we're going to have to multiply this by something that's going to give us 5 to the 4th inside of that 4th root. Hear what I just said? Because what I want to end up with, I'll erase this in a second, but watch. I want to end up with this. Would you agree? Why do I want to end up with that? Because the 4th root and the 4th power do what? They'll cancel each other out, and I'll just be left with a 5. You see that? So what am I going to have to multiply this by in order to get 5 to the 4th? 5 to the 3rd. That's not that hard, is it? Okay, so what I do is I put the 4th root of 5 to the what? To the 3rd. Don't put 5 to the 4th there, because if I multiplied those together, that would be 5 to the 5th, wouldn't it? All right, so I multiply it by 5 to the 3rd. Then when I multiply these together, that'll give me 5 to the 4th. But what I did that on the bottom. Do the same thing on the top to make it a 1, right? Everybody see that? So now, let's do the multiplication. Now the bottom's easy. Okay, we didn't just pick any old random number. Would you pick this if you just have to pick some random number? Obviously not. All right, we picked this so that when you multiply these together, the 4th root cancels out. So let's see what happens. And I'm going to show you every little step here. So it's the 4th root. When you multiply these together, you can put them both under the 4th root. So what are we going to do? We're going to take 5 to the 1st and 5 cubed, multiply them together. If I multiply them together, I keep the base the same, right? That's how we multiply these. You keep the base the same. And what do you do with the exponents? You add the exponents. 1 plus 3 is 4. And you look at this. That should look like something that's going to cancel out, doesn't it? Because you got a 4th root, you got a 4th power. They'll cancel out, and we're just going to be left with a 5 down on the bottom. So that was our trick right there. That was the key. That step was the key to doing this problem, is to understanding that you take this and you multiply it by the 4th root of 5 to the 3rd, because that gives you the 4th root of 5 to the 4th. Is that making sense? I think it's a little bit better explanation than yesterday, don't you? With the fractional exponents, yeah. So now, how do we do this? Well, they're both 4th roots, aren't they? So I could put it under a 4th root. But now what do I do with those two numbers? Just multiply them together, right? So this is just a 3, and this is a 5 to the third. Let's do a little bit in our... I'll tell you what. We're going to simplify this anyway. Let's just write it down. So it's 3 times 5 to the third. We don't leave it like this. We still got a little bit more of a simplification to do. So the bottom, we've talked about this quite a bit. So that's just going to be a plain old 5. What about the top, though? It's still a 4th root, isn't it? We can do this in our head. What's 5 cubed? We've talked about that number several times. It's 125. That's right, because 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. So that's 125. Can you do this? What's 3 times 125? 375. That's right, because 3 times 25 is 75, and that 1 is 3 times 1 is 3. So it's 375. And that will not simplify, and that's how you leave your answer. It's kind of weird looking answer, but it is simplified. Look, we took that and we simplified it to get this. And some people look at it, that looks more complicated than what we started with. How in the world is that simplified? Well, it's simplified. It's simplified because you don't have a square root in the denominator anymore. All right? And right here, you technically did, didn't you? When you had a fraction inside that root. Okay? So I said square root. I meant root. Okay? So you can't have a root, whether it's 4th root, 3rd root, square root, whatever, in the denominator. And that's your answer right there. What do you think of that? Hopefully, that made a little sense. Hopefully you took notes on this. This is the key right here. This is the only one of these I'm going to do, okay? So follow this example. The other examples are really, really close to this. And there it is. All right. By the way, when we got rid of what was that other one? 12 over the square root of 3. Here's the name for this process. Not that it's like super important that you know the name, but I think it is, because if I say do this method or do it by this certain way, here's what they call it. They call it rationalizing the denominator. That sounds fancy, doesn't it? Rationalizing the denominator. Denominator. Good thing for phonics, right? All right.
I was
So
thinking Terminator.
Terminator. Rationalize. Yeah, we are. We're terminating the square root, aren't we? So we're rationalizing the denominator. That's the name of this. So if somebody says, "Hey, I got some trouble with math. Can you help me?" Well, what are you doing? Well, we're learning how to rationalize the denominator. I'm like, "Oh yeah, I know how to do that. We just learned that today." So wouldn't that be nice? Be able to help somebody else do this. Yep. All right. Let's do another one. Here's another type. Yeah, let's do this one. Yeah, we got time. Let's go orange this time. We don't use that very much, do we? Write this one down. It's -1 over the cube root of 16. So write this down. And then it's 5 over the cube root of 128. This is not exactly what we were just doing, but it's still more root stuff. So it's a little bit of a different style of problem. There we go. But really, this is one of those problems where you already know how to do this. Even though you haven't done this exact type of problem, you already know how to do it, because all the skills that you need to do this problem, you've already learned. All right? Well, at least I already taught it to you. Whether or not you learned it might be a different story, but I did teach it to you. So let's take a look. We're adding these together, even though that's minus. Okay, we're adding these fractions together. So really, what's the most important thing to do when you add fractions together? Find a what? Common denominator. Oh my goodness, look at that crazy, ugly denominators. All right, so I'm not going to try to find a common denominator right now. And we've done this kind of thing before. What do you think you might want to do to this denominator and this denominator right here?
Factor them out.
Well, I probably wouldn't say factor them out, but simplify them, right? Simplify those two numbers. So let's see what we can do. Let's put -1 over. And we've done this before. We did this a couple days ago, actually. The cube root of 16. Now, I don't know what the cube root of 16 is off the top of my head, but I could break it down, couldn't I? Now let's think. It's a cube root this time. It's not square root, so it's not a 4, is it? All right, it's the cube root. What number times itself 3 times is going to equal 16? Well, let's think about this. Just off the top of your head, if somebody just walked up to you and say, what times what is 16? What's probably the first thing that would pop in your head? Actually, there's 2 things that could possibly. What is it? I can't hear. 4. 4 what? 4 times 4, right? Okay, or what?
16 times 1.
All right, 16 times 1. That's not going to...
the first thing.
Is that right? Well, that's not going to help you out very much, but you're right. If that popped into your head, 8 and 2, right? I'd probably think 8 and 2. But 4 and 4 would probably be just as common as 8 and 2, wouldn't you think? But let's think of the 2 things. Can you take the cube root of 4 or a 4? No. What about 8 times 2? Can you take the cube root of either one of those?
Yeah.
Yeah, cube root of 8, right? So this is one of those deals where you kind of have to pick the numbers multiplied together that are going to give you 16, and hopefully you can take the cube root of one of them. Now, you could have taken this and broken it right down into its prime numbers, couldn't you? You could have gone, what, 4 2s, right? 2 times 2 times 2 times 2. You could have done that if you wanted to, all right? But this way is a little bit more streamlined. This way is a little bit easier because I know what the cube root of 8 is. Cube root of 8 is just a 2, all right? So that makes things a little bit easier. Let's do this one. 128. Wow, nothing rings the bell for 128. But if you put it into a calculator, you could, it ends in an 8, right, which is an even number. So what would you do on a calculator? Divide by what? If it's an even number? If it's an even number, 2 will always go into it, right? Into an even number? Let's think about this. Watch. Let's do this without a calculator. Don't even touch a calculator on this. 2 goes into this. Look, 2 goes into 4.
32 times 4.
Yes, 4 goes into this 32. So 32 times 4, exactly right. What? Yes, that's right. But I was saying 2 though, wasn't I? Yeah, I was saying 2. So 2 goes into this what? 64 times. Do you agree? All right, 2 times 64. So let's write that down. So let's put 64 times 2. I don't know if this number pops in your head or not, but it does to me. You can take the cube root of one of those numbers. What is it? 64. What is the cube root of 64?
4.
It's 4. That's right, because 4 times 4 is 16. And 16 times 4, maybe that's something you can't always do in your head, but we've talked about that number a couple times this year. So 16 times 4 is 64. So I can actually take the cube root of 64. So that was a nice choice to use, wasn't it? Okay, that was better than 4 times 32, because I can actually take the square or the cube root of 64 and be done with it. All right, plus, you got a 4 on the top. Can you simplify the cube root of 2? No, so you just leave it like that. We're still not even thinking about adding these fractions together. All we're thinking about doing is simplifying those denominators. Yes?
Would it matter? So it wouldn't matter if we put different numbers in 64 and
No, you could have done that. You could have gone, look, you could have done this. 64 is 8 times 8, right? Times 2. And look at this. You could take the cube root of that. That might make it a little easier for you, right? If you didn't recognize what the cube root of 64 is, you could have done this. Because what's the cube root of 8? It's 2. And the cube root of this 8 is 2. 2 times 2 is 4. It works out the same exact way, doesn't it? Okay? So yeah, you could have done this. If you didn't realize what the cube root of 8 is, you could have had all primes right here. So you could have had like 6 2's, right? All written down here. 6 of them? 3, 6, no, it's 8 of them. You'd have 8 of them right there, right? Because 2 times 2 times 2, there's 3, that's 6, and no, 7. I can't count. 7 2's right here. All right, so let's keep going. So that's a great point. If you didn't recognize what the cube root of 64 is, you could have broken it down into that. All right? So the way I'm showing you it is not the only way to do this. So let's see what we got here. We got negative 1 on top. Let's do this. The cube root of 8. What's the cube root of 8? It's just 2, isn't it? 2 what? What's left over then?
Cube root of 2.
Cube root of 2. Don't forget the cube root. Don't leave it square root. I almost did too. That's why I said that. All right. So let's do the next one. 5 is on top. Now let's do this. Let's look at this one right here. What's the cube root of 64? We said it already. It's a 4. And then what's left over? The cube root of 2. All right. See how they rig this thing again? They make it nice, don't they? Because they made this a cube root of 2 so that you have a common denominator. And so there it is. There's the cube root of 2. All right. Now we're at a point where we can actually add the.
Hey, I need your stuff.
Okay.
You can bring all your stuff.
Yes. Okay. Now we're at a point where we can actually add these fractions together. We can find a common denominator. Okay. So now we can find a common denominator. Now look, they all have something in common, don't they? They've got this, this, and this in common. So it's kind of like this. It's kind of like 2x, 4x, and 1x. Would you agree? So if you just had a 2, a 4, and a 1, what would your common denominator be with 2, 4, and 1? Just be a 4, wouldn't it? But there's a little bit more to that. So it would be a 4, but then it would be what? You also have what else in common? That cube root of 2. So that's your common denominator. Really wasn't that hard to find that common denominator after you simplified everything. So finding the common denominator really wasn't the big deal. The big deal was simplifying the denominators of those two things. All right. Once you did that, then again, they've rigged this thing to make it kind of easy to find a common denominator. All right. So what do we do to find the numerator? We look at this denominator and say, what do we do to this to get to this? 2 times what? 2. So you multiply that by 2 as well. So that gives you a negative 2. Okay, put a minus. What'd you do to this to get to this? Nothing really, right? But technically you multiply by 1. But so we'll just put a minus 5 right there. What about this? What do we do to this thing right here to get to this? What do we multiply this by to get to this? A 4, right. Okay. You see that? Because this doesn't have a 4 on it, this denominator. We multiplied it by 4 to get to this. So if I multiply the bottom by 4, I got to do what? Multiply the top by 4, which gives you plus 16. We good? Let's keep going.
Yes, still have to add all.
Yeah, we still got to add stuff together, and you're going to have a cube root on the bottom. So we still have a little bit more to do. All right, so don't get too excited. All right, so what do we got? Negative, what, 7 plus 16 is, what's that, 9? Or 11, isn't it? Well, it's 9. Right, I can't add. It's 9. And then, what do we have on the bottom? 4 cube root of 2. Looks like we're done, but look at it. What did we just finish doing? We just finished doing a problem where we can't leave it like this. You can't have a root in the denominator, can you? So now we get to try that other thing. So you should be kind of excited about, about doing that thing. So what are we going to do here?
Multiply by cube root of 2 by cube root of 2.
No, not just the cube root of 2. Cube root of 2 is not going to get rid of that. It's going to be the cube root of 2 what? 2 squared. That's right, because look, this is 2 to the first, this is 2 squared, right? That's going to give you 2 cubed. That's how you're going to get rid of your cube root. Make sense? So if I just multiplied by 2 to the first, I would get the cube root of 2 times 2, right? Or 2 squared. The cube root doesn't cancel out the squared. The cube root only cancels out a cubed. So I got to make this 2 squared. So 2 to the first times 2 squared is 2 cubed. You getting that? Now you got to do it to the top as well. Well, no, you don't need the 4 there because you don't have to get rid of the 4. The 4 is fine on the bottom. The only thing you have to get rid of is that cube root. Okay, so the 4, I mean, you technically could, but then they're going to cancel out in the end anyway. But you don't have to multiply by the 4. Just get rid of the cube root. All right? And we are almost done. So let's see what we get. On the top, you get 9 times the cube root of, let's not keep it 2 squared. Yeah, make it a 4. Make it nice and pretty. All right, and on the bottom, look what we get. We get a 4 on the bottom, right, because it's being multiplied. Now, what's this deal? This is, let's do a little side step right here. This is going to be what? The cube root of 2 cubed. What's the cube root of 2 cubed? What is it? It's just 2, right? Because the cube root cancels out the cube. So I just have a 2 left over. That 2 is being multiplied by the 4. Almost done, but that last step's super easy, isn't it? So really, it's just 9 cube root of 4 over what? 8. And then there it is. I agree. That was a little bit, that was a few steps. All right, but look, we're not in Algebra 1 anymore. Okay, you can't expect the problems to be just 1 or 2 steps. All right, this is college algebra. All right, you get that first word? College means it's harder than high school. Okay, so there are times when you're going to have to do quite a few steps. Look, there is no way in the world that you're going to be able to just sit there and just watch what I did and be able to get it. There's just no way. All right? You have to do it yourself. Even if you took notes, there is no way, if I give you a problem like this, that many of you, maybe most of you, will get this right. You have got to practice this. You have got to on your own. Wendell, in football practice, do you guys get together and then the coach says, okay, we're running a new play. Here it is. Okay, Wendell, you're gonna fake the handoff. You're gonna go over here. You're gonna block that guy. You're gonna chip that guy. You're gonna come out here in the flat for a pass. Okay, if that's not open, then so and so is gonna, Freddie's gonna do a fly route out there. And if that's not working, so and so. All right, everybody got it? Yeah, we got it. Boom. You go and you never practice it. You go in the game and you expect to be able to do it. No, of course not. You've got to practice it. It's like anything. Okay, you have to practice it. Look, just sitting there watching me is like watching a play for the first time and then going into the game and never practicing it. You have got to practice this. Practice the same exact example. Okay, practice the same exact thing. You guys have your book. Now I give you worksheets and stuff, but you have your book, and if you looked, the odd answers are in the back. So what you could do is go to this lesson, find a problem that looks really close to this, hopefully an odd number, so then you can practice that one, and then go in the back of the book and see if you got it right. Okay, you've got to practice. You can't just sit there, watch me do it, and just expect, just because you were nice and quiet and you're a good student and you took notes on it, that you're going to get it. It's not going to happen unless you go the extra mile and you practice this stuff. You must practice this. Okay? All right. I'll pep talk with that. I got to show you one more problem. Sorry. I know it's a lot of stuff to throw at you, but that's the deal. Let's do one more type of problem. Look at this. We're going to do simplifying again. And look at that. That doesn't look so bad, does it?
Thing is,
Or does it? I don't know.
how exactly do you plan to?
Get rid of the square root?
Yeah.
Yeah, good question. Got that same question myself. Don't you? Do you just multiply by square root of 2? That's what we did before, isn't it?
No.
Because watch what happens. Now, don't write this down, okay? Because this is not right, so don't write this. Some people try this. Oh, I square root of 2 on the bottom, so I multiply by square root of 2 over square root of 2. But what happens if you multiply this by this? Look what happens.
You still get a square root of 2.
That's right. You still have a square root of 2 on the bottom, don't you? That's what your denominator would be if I multiplied those two things together. So round and round we go, right? Where we stop, nobody knows. Didn't you say that when you were a little kid? So you can't do that stuff, can you? Because I still will have a square root in the denominator. You guys remember that difference of two squares stuff, right? We talk about that all the time.
Yeah, that's what I was wondering.
Watch this. Let me show you a nice little easy problem. Let's go 1 plus, I don't know, let's just say square root of x. I'm not going to get you to think about why this works. I'm just going to show you that it works. Watch this. If I took this and I multiplied it by something that's going to make it a perfect square, all right? So what would that be? It'd be 1 what? Minus the square root of x. Now that looks like a difference of two squares, doesn't it? So guess what happens? All we got to do is multiply the first and the last. So let's multiply the first. We get 1. The outside and inside will add up to 0. So now we multiply the last. Now here's the key. Look what I'm doing. I'm multiplying a square root by a square root. So what's going to happen to that square root?
Negative x.
It's going to go away, isn't it? Okay, so it's going to be minus square root of x times square root of x is just x. Look what we did. Just like magic. We got rid of the square root, didn't we? Exactly. That's what we do up here. Does that make sense to you? We call this thing, let's give it a fancy name. See how this is 1 plus square root of x and we made this 1 minus square root of x? We kept it exactly the same except we just changed the sign in the middle. We call this thing a conjugate. Conjugate. Alright? So what we're doing is we're multiplying by the conjugate. The conjugate is you just change the sign in the middle. Everybody see that? Not that big of a deal. So you change the sign in the middle, that's the conjugate. So let's go back to this. Let me erase this. And I'll do the conjugate in a different color. We haven't done this purple today. So what we have to do is not just multiply by the square root of 2. We're going to have to multiply by what? What's the conjugate of this? It's 1 plus the square root of 2. Right, you just change the sign. Now, of course, we do that on the bottom. What? We do that on the top. Why do we do that? Because we're multiplying by a 1. Right. Okay, so that's just a 1, isn't it? We're not changing the value of it at all since we're multiplying it by a 1. So let's do this real quick. We're almost done. the conjugate part's the easy part. That's the fun part. I love multiplying by the conjugate because all you got to do is the first and the last, right? You don't have to do the outside and inside. So let's do that. 1 times 1 is 1. Negative times positive is negative. Square root of 2 times square root of 2 is 2. Very nice. What about the top? Look at the top. That's really easy since you had a 1 there. Yep, distribute it, but it's a 1, so it doesn't really change. Now, this is not always going to be a 1, right? They could put a different number there. But in this example, it is. Yeah. Now, do we leave it like this? No. You look at this. What are you going to have to do? Yeah, minus the bottom, right? So 1 minus 2 is negative 1. Now, this is really not the best way to write this either. Because if you take a look at it, both of these things are being multiplied by negative 1. So here's the nicest way to write this. What's 1 divided by negative 1? It's negative 1. What's positive square root of 2 divided by negative 1? It's negative square root of 2. All that did was just change the signs of both of those. Nope, I want you to keep it like this. Okay, this is how I want you to keep it, right there. All right, so don't leave it over negative 1. Make sure you divide everything, both of those things, by negative 1. Okay? So that's how you get rid of a denominator like this. That's a sum, all right? Sum or difference. You multiply by the conjugate, works out nice and pretty. Now sometimes, though, this numerator might not be so pleasant. All right? Sometimes it might be another square root. Sometimes it might be another sum of a square root. It could be like a 2 plus square root of 3 or something like that. All right? So it might not quite be as easy as this, but the process is exactly the same. We multiplied these two together. Again, sometimes this number is not as easy as 1, but you still know what to do if it's a regular number. All right? Well, we went a little longer today than normal, 30 minutes. We don't usually go 30 minutes on the lectures, but we needed to. All right? Now look, again, go back, watch the videos. I know I went kind of fast in some spots. Okay, there might have been some places where you're a little confused. On that one problem, the one before this, look at all those steps we had to do. There was a lot of steps there, weren't there? All right, so what you have to do, watch the video once, just go to this spot right here. Don't watch the whole 30 minutes. Just go to this spot right here. Just sit there and watch it. Don't do anything but sit and watch it. And then go back, write the problem down, and try it on your own without any notes, without anything in front of you. Give it a shot. See if you can get it right. If you didn't get it right, go back on the video, try to find out where you went wrong. That's the kind of stuff that you should be doing. If you're not doing that kind of stuff, and you're getting it wrong and you have no clue how to do it, then you're not doing enough. Right? You can't just say, well, I don't understand it. I don't understand it. Because people do that all the time to me. Well, I just don't get it. I just don't get it. Well, there comes a point where you have to get it. I've given you enough information. I've given you every little step of this problem. You have to take responsibility on your own and go and do that. That was the biggest thing that I learned from college. Okay, this is my hint to you about college. The biggest thing that I learned, one of the biggest things that I learned when I went to college that I was not prepared for, is people just expecting you to be able to get it after they present the information. All right, our professors would sit there and boom, go through the whole thing. Yeah, they might take some questions in class and stuff, but they expected you to be able to do it the very next day and to be able to do the homework that night. Was I smart enough to just sit there in class with my arms folded, just watching the professor teach and just get it right away? Absolutely not. I was, oops, oh my goodness, I'm getting excited throwing pens around. I was completely dumbfounded sometimes. I'm sitting there, I'm just shaking my head inside, right? I'm not doing it so he can see it, but thank you. Inside, I was just shaking my head and thinking, I have no idea what he's doing. You've got to be kidding me. He expects me to be able to do that, all right? You guys ever have that feeling? Yeah, I see it in your eyes. I see it in your body language. I see it in your expressions. I understand that. I've been there. I've done that. But the thing is, I didn't just blow it off and say, oh, just couldn't get it. All right? I'll have my mom write him a note and say, I just couldn't get it. No, they don't care. All right? You are one step away, most of you, to go to college and be under situations like that. What did I do that night? I studied really hard on my own, and I also got together with people in my class. I made friends with people in my class and we'd have a study group together, and I would work together with them. I'm like, look, I had no idea what he was doing today, and hopefully one of my friends, and usually they were smarter than I was, all right, which made it nice, but they would help me out and say, yeah, this is, you didn't understand this part, this is what he did, and they went through it, once or twice, and then I finally was able to get it. But it took hard work. It took a lot of perseverance. I didn't just get it right away, all right? So don't think that just because I'm the teacher and I'm going through this that I don't know how you're feeling. I know exactly how you're feeling. I was always out of my little study group of my friends, I was always the dumbest one. All right? I mean, I say that literally. I was the dumbest one out of my group of friends, and they always had to help me all the time. Okay? I know what it's like to be there and struggle, but I didn't use that as an excuse. Did it bother me? Was I frustrated? Did I get ticked off sometimes? Absolutely I did. But I didn't let that be my excuse. I had to work harder than what my friends did to figure out how to do this stuff. And I have a feeling some of you guys are just sitting back and just expecting to get it, and if you're not soaking it in, oh well, whatever. You can't do that. You've got to put the extra time and effort into this. I did it. You can do it. I was not the smartest math person in my group or definitely in my class. Oh my goodness, okay? I felt like the idiot in my class. I really did. I mean, I'm not just saying that. I did. I felt so stupid. But the thing is, I worked probably twice, 3 times as hard as some of the other people in there to be able to get a C, and those guys were getting A's, Sometimes that's the way it goes. We're not all built the same. We all don't think the same. Okay, so you've got to put some extra effort out. And some of you guys I don't think are doing that. And I know some of you guys have much more, you've got much more potential than what you're showing. All right, it's just a matter of hard work. Okay, sorry. Probably nobody listened to that. There's nothing on the screen or anything, but that's okay. All right, I'm going to give you the worksheet. And the worksheet is, what's it, 17B. So it's 17B. And you should be able to do just about every one of those, I believe. Okay?